Let's take the mystery out of forming a max term. We're going to talk about what is a max term, right? How are they formed and how are they used in this quick tutorial? Right, so a max term is a sum term that will output a value of 0. So we're always going to write it in a form so its output value will be a 0. A sum term in digital logic is formed using the logical OR, right? It's the logical equivalent of mathematical addition, and you'll often see the relationship, the Boolean relationship, written with a plus sign. So it looks as though we're summing something. So a max term is a sum that outputs a value of 0. Right? As a reminder of the OR gate truth table, the only time the OR gate will output a value of 0 is when all of the inputs to the OR gate are 0. Right? In this truth table, we have two inputs, A and B. You can see in this first line, the OR gate output F is a 0 when both of the inputs are zeros, right? Otherwise, when either one or both of the inputs are ones, our output is a 1. So remember, the OR gate only outputs a 0 when all of the inputs are 0. That means when we form max terms, all of our inputs to our OR gate will have to be 0 in order to output that value of 0. All right. So remember, max terms, we're going to OR them together. Whenever any of the input values are 1, so 1 valued inputs are going to be inverted. So let's take a look at what happens if we have two inputs, A, B. If we were to OR A with B, and A is 1 and B is 1, we know that that would produce an output of 1. If we're forming a max term, we want to be able to write the expression A ORed with B and produce an output of 0. In order to do that, we have to invert A and we have to invert B. And we write the max term expression as A naught ORed with B naught. If we invert 1, so 1 naught ORed with 1 naught becomes 0 ORed with 0, and that produces an output value of 0. Right, let's take a look then at all of the max term expressions for a two input function. Again, where our input names are A and B. The max term expression for A ORed with B when A is a 0 and B is a 0, right, the max term expression is A ORed with B, right? Because 0 ORed with 0 will produce an output of 0. And when we number max terms, you'll sometimes see them written in a notation of a capital M followed by a 0. That means max term 0. Right. Let's take a look at our next set of possibilities when A is a 0 and B is a 1. Well, we know 0 ORed with 1 would produce a 0. That's not the result we want. We need to OR A ORed with B and come up with a value of 0. So we simply A ORed with B naught. So again, when any of the inputs are a 1, the max term expression inverts that variable. So A ORed with B naught is your max term 1. When our input A is a 1 and B is a 0, we have to invert the A because it's a 1. So our max term expression is A naught ORed with B. That is max term 2. And we use these decimal numbers too to indicate, right? It's easier for us to work with the decimal numbers. If we want to convert that to binary, right, we know 2 would be an input of 1, 0. Finally, our last possibility, A is a 1, B is a 1. We have to invert both A and B. We write the max term expression as A naught ORed with B naught, and we call that max term 3. So as you can see, right, in these max term expressions, anywhere where the input variable has a value of 1, we invert it to write the max term expression. Let's take a look at what happens when we have a table of 3, right? So when all 3 inputs are zeros, well, 0 ORed with 0 ORed with 0 produces a 0, so our max term expression is A ORed with B ORed with C. Right? When A is 0, B is 0, and C is 1, we have to invert C. Our max term is A ORed with B ORed with C. So it follows this rule of when your input variables have values of 0, you don't invert them. When they have a value of 1, you invert them. Because a max term is a summing term, we OR them together. So we use this symbol for logical ORing to form max term 1. Here, max term 2, well, A and C are both zeros. We don't invert them. B is a 1. We invert that. And let's bring up then the table here. Grab my window, but it was being interfered with. All right. So max term 3 here. Well, that's going to be A is a 0. So A ORed with B naught, ORed with C naught, because B and C are 1s, and that is our max term 3. Right. Here when A is a 1, so it's A naught ORed with B, ORed with C, max term 4. Right. In this row, 1, 0, 1, well, A is a 1, so A naught ORed with B, ORed with C naught, right? B is a 0, C is a 1. There's your max term 5. Right. A naught ORed with B naught, ORed with C, inverting the 1s, keeping the 0s. A naught ORed with B naught, ORed with C naught is max term 7 because all of our inputs are 1s. So if we invert the 1s, we end up with 0, ORed with 0, ORed with 0. And that's all there is to it in terms of forming max terms. Right? Remember, max terms are summing terms. So they're formed by ORing the binary input values. The result must be a value of 0. And that means we need to invert any of the inputs that have a value of 1. Right? Our last question, right? How do we use max terms? Well, we use max terms in a standardized digital logic equation that we call product of sums form, right? Where the sums are the individual max terms. So A ORed with B ORed with C, this would be max term 0, right? 0 ORed with 0 ORed with 0. And the product is the ANDing. So this sum is ANDed with this sum, this max term sum. A ORed with B naught, ORed with C naught. What max term do you think that is? Well, A must be a 0. B and C must be 1s. This must be 0, 1, 1. So this is max term 3. All right, I've got another tutorial coming up on how we form different product of sums expression and how we use those max terms. All right, so hopefully this has helped you learn how to form max terms. Go out and practice with some different variable combinations. Just write down those few steps and you'll be able to always form any max term you need, no matter how many input variables. Thanks for watching.